Okay, we're doing a problem that is about percent yield. And we have a reaction here. Zinc is reacting with hydrochloric acid and it's producing zinc chloride and hydrogen. This is a reaction that's used in the process of making bronze. So what we have is we have 25 grams of zinc in that sample, and we want to determine what's the theoretical yield of this gas, of the hydrogen gas that's produced in this piece. So we're going to begin, and of course when it says theoretical yield here, we're basically asking you to find the amount, the grams of hydrogen that you're looking for. That's basically what we're trying to find here. So we begin with our 25 grams of zinc, and we pop it into our skeleton here. 25.0 grams of zinc. We're going to change it to moles of zinc by using the molar mass, right? So we're going to have 1 mole of zinc, and the molar mass is 65.39 grams of zinc in that 1 mole. But we aren't quite finished yet here. We're going to go from moles of zinc, and we're going to transform that into moles of H2, right? Because I'm trying to go from grams of zinc to grams of hydrogen. So we'll extend our line, and we'll go moles of zinc on the bottom. And on the top, we'll put moles of H2. Now I look up in my reaction. Here's my zinc, and here's my H. There's both 1s there. So we'll put a 1 for each of those spots. And of course, you know, the reason I know that this goes here is because the units always go down. The units go down. The units go down. So therefore, on the bottom, I will have moles of H2, and on the top, I will have grams of H2. Since it is 2 hydrogen, I'm going to double the amount. Instead of it being just 1.008, it'll be 2.016 in 1 mole. Always in molar mass, these 2 steps, you're always using 1 mole with those grams. Okay, so I do my calculations, and I find that this produces me 0.771 grams of H2. I use 3 significant digits because this is 3 significant digits here. And this is my theoretical yield. This is the amount that if everything goes right, if you get 100% efficiency, this is the number that you are going to get. Now the problem comes back and tells me that your reaction produces, so the reaction produces 0.680 grams of H2. And they ask you to determine the percent yield. So, in order for me to do this, I need to compare these 2 numbers, the 0.68 and the 771. I'm going to compare those things. To get percent yield, we do actual divided by theoretical and multiply it by 100. Because we're getting a percent. Just like on a test, if you were to get 8 points out of 10 on your test, you know that you got an 80%. Same principle here. So we're going to take these 2. This, of course, being my theoretical yield, 0.771, and 0.68 is my actual yield. So let's do the math. 0.680 divided by 0.771. And when I do that in my calculator, I get 88.2%. That is the amount. So I was supposed to have gotten 0.771, but instead I only got 0.68. So I was 88.2% efficient. These problems are going to be where you are trying to determine the theoretical yield of something. Maybe it'll be something that's combined with a limiting reactant. You could combine these into one big problem where you're using that limiting reactant here as that 25 grams. If I would have told you, say, how much hydrochloric acid you used also, you could have found your ratio. But this is the plan for percent yields.